Hi, my name is Win Karnichi Rotopong and today I'm going to be explaining my exam paper. So for the first question is this graph. We have a graph over here and arrows. We were also given these, the pressure, the volume, and the temperature on each point. So for A, it asks for the start of ignition, the pressure over there, and it is P3, as you can see over here, and P3 is 30 bars. Determine the maximum pressure after the start of ignition. So it's over here because after the start, this is the start and going up 60 bars. For C, determine the temperature in Celsius at point 3. Since the volume is the same, we will use P3 over T3 equals to P4 over T4. Put the numbers together, and since the Celsius has to be converted to Kelvin, we have to plus 273. So that will equal to 1546 Kelvin. T3 is equal to P3 times T4 over P4. Put the numbers together and we will get 773 Kelvin minus 273 to get Celsius back. So the Celsius will be 500 degrees Celsius. Some questions I didn't answer fast enough, so I just left it there. Determine the suction volume. V suction is equal to V2 minus V1. Put the numbers together and you'll get 550 centimeters cubed. Determine the displacement, or S, given that the piston diameter is equal to 80 millimeters. For the formula over here, we can't use millimeters, so turn 80 millimeters to centimeters. That will equal to 8 centimeters. V suction is equal to pi times d over 4 times s. Put all the things we know together and put s at the front. S will be equal to 550 times 4 divided by pi times 8. The answer is 87.53 centimeters. Determine the compression ratio. The compression ratio is VB max over VB min. Since VB max is equal to V2 or 600 and VB min is equal to V1 or 50. Divide that and we get 12 centimeters cubed squared. Determine the volume of piston at TDC. Now TDC is top dead center and has the least amount of volume, which is 50. So 50 will be the answer. Next, on to number 2. Number 2, we have to find the diameter of the cylinder in cm, the compression ratio, the stroke ratio, and the crankshaft ratio. We were given that V suction is equal to 765 centimeters cubed. D is equal to root 4 times V suction divided by pi times S. S is 110, but we can't use it in millimeters, so change that to centimeters, which will be equal to 11 centimeters. Put the numbers where they belong and you'll get 2.97 centimeters. The next one is the compression ratio. V suction plus Vc divided by Vc. You have to find Vc, so Vc is equal to pi times D2 divided by 4 times S. Put the numbers together and we will get 76.2 centimeters cube. Put that in the original formula and you will get 2. Now for the stroke ratio. Yes, stroke ratio is equal to S divided by D. S over here, and all of this is in millimeters. So 11 divided by 94 is equal to 1.17. The crankshaft ratio is equal to R divided by L. R is the radius of this, and L is the length of the connecting rod. Put that together, which is equal to 0.25. Now for petrol engine, it is around 2.21 to 2.31, and we have 2.25, which means that it is a petrol engine. On to number 3, we have to find the piston movement, the maximum burst pressure, the normal force, tangent force, radial force, and the torque. We were given that F is equal to 24,000 newtons, D is equal to 90 millimeters, beta is 10 degrees, and I forgot what the other one is called, but it is at 120 degrees. But this is not alpha, so we need to find alpha. So 10 plus 120 plus alpha will be equal to 180. Put those numbers together, which is 130, and we can find how much more we need till we get 180, which is 50 degrees. Now we will put it all in the formula. Sk is equal to RL, R plus L, minus R cos this alpha plus L cos beta. Put the numbers together and we will get 12.53 millimeters. P max or burst pressure is equal to F divided by A. A is equal to pi times D2 divided by 4. Put the numbers together and we will get 6,361.72. F is equal to 24,000. Divide that and you will get 3.77 bars or 37.7 newtons per centimeter square. Normal force or Fn is equal to F times tan beta. Put it all together, we will get 4,231.84 newtons. Tangent force is equal to F. Actually, tangent force and radial force is nearly the same, except this is sin and this is cos. So F times sin A plus B, or alpha plus beta, divided by cos beta. The same, but except sin is equal to cos. So put the numbers together, and for tangent F, force tangent, we get 21,105.24 newtons. Radial force is equal to 12,185.119 newtons. And lastly, the torque. M is equal to torque, and M is equal to Ft times R. But the R over here is in millimeters. We need to use meters. So divide that by 100, which is 0.03. So put the numbers together and you will get 633.15 Newton per meter. Lastly, we have the we have to find the estimate of the fuel consumption rate, or MK, and the power loss. We were given that X is equal to 4-stroke, which is over here, RPM is equal to 9,500, HU is equal to 42,000, PZU is equal to 117 kilowatts, V suction is equal to 450, average PI is equal to 11 bars, and R is equal to 30 millimeters, and M is equal to 0.85. Now on to A. It asks for MK and power loss. For MK, we can use this formula. MK PZU equals to MK times HU divided by 3,600. Put the numbers together, and the formula for MK is equal to PZU times 3,600 and HU. Now we put the numbers together and we will get 10.02 kilograms per hour. Power loss. Power loss is equal to PI and is equal to PZU minus exhaust loss plus cooling loss. Put that at the front and we'll get the power loss is equal to PZU minus PI. But PI we need to get in kilowatts. So PI in kilowatts is equal to V suction, PI, and N divided by X times 300. X is the amount of strokes needed for one cycle. So 4, and we put all the numbers together, we will get 39.18 kilowatts. So now for the actual power loss, PZU minus PI, 117 minus 39.818, and the answer will be 77.82 kilowatts. For B, it asks us to find the P efficiency, the F tangent, and torque. So the P efficiency is the formula is Nm times Pi, and that is 0.85 times 11, which is 9.35 kilowatts. The tangent force, we need to use this formula. P efficiency equals to Ft times R times N divided by 9,550. But since we need to find Ft, we have to put it at the front and put the front, and it will be Ft is equal to P efficiency times 9,550 divided by R times N. Put the numbers together and you will get 313.30 N. Now lastly, for the torque. Since we can't find torque, we have to use P efficiency equals to torque times N divided by 9,550. And put the torque at the front, which is equal to 9.35 times 9,550 divided by 9,500. The answer will be 9.39 newtons per meter. And that is all. Thank you.